A number of the videos in the guided tour series have illustrated the many interactive graphs in at-risk: histograms, scatter plots, tornado graphs, and others. Graphs are clearly a very important aspect of at-risk, and there are many ways to change them and interact with them. This video will illustrate some of the possibilities. There are obviously some overlaps here with other videos in the series, but the focus of this video is entirely on at-risk graphs. The model shown here is of a new product introduction. It will be used to illustrate the possibilities. It is adapted from one of the at-risk example files. There are uncertain inputs in the cells with green font, and these lead to the single at-risk output, the NPV of profit, in the maroon font. First, there are graphs of theoretical input distributions. You find these from the Define Distributions button on the at-risk ribbon. In fact, this is often how you enter distribution functions for uncertain inputs. As an example, here is the PERT density for the development cost. This is a continuous distribution, so it is shown here as a smooth curve. As in all at-risk graphs, there are two vertical bars, or sliders, that you can move to see probabilities or percentiles of the distribution. By default, they are set at the 5th and 95th percentiles, but you can move them. Alternatively, you can type values or percentages directly for more precision. All at-risk graph windows have a number of buttons at the bottom. The left 5 buttons are always available: Help, Graph Options, a button for editing or exporting the graph, the type of graph, and a graph overlay. These 2 buttons for zooming in and out are also always available. Now, in a little more detail, this button opens the Graph Options dialog. As in Excel itself, the options are almost limitless. You will probably be perfectly happy with the default options, but you can change them as much or as often as you like. This button provides the following choices. For example, you can create a chart in Excel. It won't be interactive, but you get a picture of it. Or you can copy the graph and then paste it into any other document, like a Word document. This button lets you change the type of the displayed graph. Here are the possibilities. We're currently looking at a probability density. Here is a cumulative ascending distribution, or a cumulative descending, or a relative frequency, like a histogram, where you see bins. Or I'll change it back to probability density and superimpose an ascending cumulative graph. Or get rid of that. This button is for overlaying another distribution on the one you see. For example, I will try a triangular distribution. This is useful for comparing distributions. Or I can get rid of it. The graph of a discrete distribution, such as the distribution of the product lifetime input, is basically the same. The difference is that it has a spike above each possible value, that is the probability of that value. The buttons at the bottom of the window provide the same options as before. Things change slightly when you run a simulation. and then look at the distribution of an at-risk output in the Browse Results window, this window right here. There's the NPV of profit. You see the same 7 buttons at the bottom as described earlier. But there are now new ones. Also, 2 of the same buttons work slightly differently. For the graph type, there are now 2 options at the top: probability density and discrete probability. At-risk has some rules for deciding whether an output distribution is continuous or discrete, and it shows the corresponding graph by default, in this case, a density function. It will sometimes decide that the distribution is discrete, and hence display a spiky graph. If you would rather have a smoother graph, you can change the type to probability density. Discrete would look awful here, as I will show you. You can also change in the other direction if you like. Also, the Graph Overlay button now lets you choose an input or output cell for the overlay. For example, here is the NPV density with an overlay of the development cost density. As you can see, they share the same horizontal scale, so it is impossible to gain any insight from this graph. I will clear the overlay. In this case, you can get much more insight from this scatter plot button. When you click it, you can select another input or output cell for a scatter plot. I'll choose development cost. This graph shows a point for each iteration, and the numbers in the red boxes are the percentages of points in each of the 4 quadrants. This particular scatter plot indicates that there is almost no correlation between NPV and the development cost. There are several situations in at-risk where you can see a matrix of scatter plots. One is where you click the tornado button on the at-risk ribbon. Then by clicking the middle button in its bottom row of buttons, you will see a scatter plot of each output versus each of the inputs. Here there's only one output. If there were more outputs, they would be over here. And if you drag one of these, you get a full scatter plot for that particular input versus the output. I'll talk more about that in a minute. A second case where you can get a matrix of scatter plots is when you build correlations into input distributions through the Define Correlations button on the at-risk ribbon. I will do this quickly for a few of the inputs just for illustration. I'll correlate these 3 inputs. Now they are correlated, and if I run a simulation and then click one of the yellow cells, I get a matrix of scatter plots between the correlated inputs. Again, I can drag any one of those off to blow it up. Now I will get rid of the correlations and rerun the simulation again. Getting back to the output again and exploring the buttons, this button creates a tornado graph. As you can see, there are a lot of options. I will only look at the first one. Tornado graphs are discussed in detail in the sensitivity analysis video in the Guided Tour series. This particular tornado graph indicates how the mean NPV varies as each of the inputs varies through its distribution. Clearly, the product lifetime has the greatest effect on NPV. A really nice feature of any at-risk tornado graph is that you can drag any of the bars off the window to get a scatter plot of the output versus that input. You saw something like this before. Here, the blue points are for the lower 10 percentile of the input distribution, the product lifetime distribution. The green points are for the upper 10 percentile. And again, the numbers in the boxes show you the percentages of points in each of the 4 quadrants. Moving on, this button leads to one of 2 possible types of graphs, a summary trend graph or a summary box plot graph. Each is useful for showing the distribution of an output range, usually a time series range. To see this option, I will temporarily designate the net profit row, row 35, as an at-risk output range. Then I will click this button, click Summary Trend, and highlight my new output range. This is the summary trend graph, or another option is the summary box plot. Each of their legends indicates how each graph shows the mean of the output through time, the yellow line, as well as the variation around the mean at each time point. There are 3 other buttons at the bottom. This is for analyzing scenarios. This is for creating a filter. And this is for fitting a distribution to the data. There is a separate video devoted to each of these topics in the guided tour series, so I won't discuss them further here. By now you should have an appreciation for the many graph types and graph options available in at-risk. As with many other types of analysis in today's computerized world, an important key to understanding simulation models is visualization. And at-risk does its best to provide you with a variety of insightful visualization tools. This video has certainly not shown all of the options, so don't be afraid to click buttons, drag things, and right-click things. In short, don't be afraid to experiment. You might just happen upon a really nice and insightful graph.